Hi, I'm Temitope Adeniji, and you are welcome to Organic Chem Clinic, where chemistry becomes crystal clear. In this episode of Organic Chemistry, I'm going to walk you through the IUPAC nomenclature of organic compound. In the past years, I've interacted with several chemistry students, and what they have to say is that organic compounds are too confusing to name. But in this video lesson, I'm going to reveal the secrets to you. Before we go into the main topic of discussion for this lesson, we need to understand that there is a clear difference between the order of naming organic compounds and the rules of IUPAC nomenclature. This is new to you, right? I assure you that those long, scary names will suddenly become simple codes you can crack. So in today's lesson, I will take you through the step-by-step of IUPAC system. IUPAC is the standard chemists all over the world use to identify organic compounds. IUPAC is the systematic approach for naming organic compounds. What does the acronym IUPAC means? IUPAC. I is international, U is union, P pure, A applied, and C chemistry implies international union of pure and applied chemistry. So from this moment, grab your notes, stay with me, and let's turn IUPAC nomenclature into your easiest chemistry skill. So when naming organic compound, our main focus should be on the order of naming organic compound. What is this order of naming organic compound? The first thing we need to understand is that the IUPAC nomenclature of organic compounds follows this order of arrangement of the name. As an organic chemistry student, when you are asked to name the organic compound, you need to follow the order of arrangement of the names. Now, the first thing we need to understand is that the order has a particular pattern, which is prefix, word root, and suffix. The prefix is also known as the substituent group in the organic compound, or the side chain that you have linked to the carbon skeleton. The word root indicates the carbon skeleton in the organic compound, that is the longest continuous carbon chain, while the suffix reflects the functional group or the functional name in the compound. The first thing we need to understand is that the prefix which we have in group A includes the substituent attached group, which include the alkyl group, the alkoxy group, and the halogen. Let us take the alkyl group right here. The alkyl group includes the methyl group, the ethyl group. Now the methyl group has the molecular formula CH3, while the ethyl group has the molecular formula C2H5. Here we have the methyl and the ethyl group. After the ethyl is the propyl, the butyl, and so on. The next one is the oxygen to alkyl, which is called the alkoxy. Now the alkoxy, the simplest alkoxy group that we can have is the methoxy. Then the next one is the ethoxy. We have the propoxy, as indicated right here, methoxy, ethoxy. The next group is the nitro group, NO2. The nitro group can be found attached to the carbon skeleton as well in an organic structure. And the last one for this group is the halogen, the group 7 elements in the periodic table. We have the fluorine, bromine, iodine. When they are found in substituent position, they are assigned the name fluorine, fluoro, chlorine, chloro, bromine, we have the bromo, and the iodine is the iodo. Recall that in my previous video lesson on functional group, I explained that the atom or group of atoms that we have in group A right here We cannot differentiate them by order of priority, but we consider the alphabetical order of arrangement of this atom or group of atoms. Now let us consider the order of arrangement of these groups based on their alphabetical order. Now the first thing we need to understand is for the alkyl group right here, we have methyl and the ethyl. In alphabetical order of arrangements, the ethyl comes before methyl. So I'm going to assign 1 to the ethyl group, which implies that I have higher preference for ethyl over the methyl group based on their alphabetical arrangements, E before M. So in any IUPAC nomenclature where ethyl and methyl group exist in the carbon skeleton, we are expected to consider the numbering from the ethyl group towards the methyl. In other words, I can equally say that the ethyl group has priority over the methyl group based on the alphabetical arrangements. The next one is the alkoxy group. We have the methoxy group right here and the ethoxy group here. So which of these two will have higher priority based on alphabetical arrangements? That's right, the ethoxy has priority over the methoxy. Is that taken? The next one, we have the halogen group. When you are asked to arrange the halogen in order of priority, we consider their alphabetical order of arrangement as well. So in alphabetical order of arrangements, we have the bromo as number 1 here, followed by the chloro, followed by the fluoro, and the last one is the iodo, which implies that bromo has priority over chloro, chloro has priority over fluoro, and fluoro has priority over the iodo. So in that order, we need to number our substituents in the organic structure. Moving on, we have a question right here on our CYK. Check your knowledge. Arrange the following atom or group of atoms in decreasing order of priority. We have the ethyl group right here. We have the ethoxy group, the nitro group, the bromo group, as well as the chloro group. So I would like you to pause the video while you answer this question. All right, can we answer this question together? The first thing we need to understand is the alphabetical order of arrangement of these atoms, of group of atoms, must be considered. So if we have this group in the organic structure, how do we arrange them in the prefix position, which is the first group that we have right here? So we look at the group and consider their alphabets. Now the first thing we need to understand is in this arrangement, I will assign number 1 to the bromo right here. After B, we have the C, which is for the chloro. Now, I would like you to look at this closely. These two groups are kind of complicated in the sense that this is ethyl group, and also we have the ethoxy group right here. Now let's check this on the table. We have the ethyl group and we have the ethoxy group. In alphabetical order of arrangement, both groups start with the same alphabet, which is what? E. But we need to look at this closely. We have the E, C, H, which is similar to both groups, but the next alphabet after H is Y right here, while the next alphabet after H here is O. So which one comes first? That's right, the ethoxy comes before the ethyl. So I'm going to assign number 3 to ethoxy and number 4 to what? The ethyl group. So the last one is the nitro group. Okay, so therefore I can equally say that in order of priority I have bromo greater than chloro greater than the ethoxy greater than the ethyl, and the last one is the nitro group. Okay, this is the correct order of arrangement of this prefix in an instance whereby they are all found in the organic structure. Make sense? Moving on, we are still considering the order of naming of organic compounds. So the next phase is the word root, which is our group B right here. Now, what does word roots imply? The word root indicates the carbon atom present in the longest continuous chain. So we need to check how many carbons are there in the longest continuous carbon chain, which is also known as the carbon skeleton in an organic compound. Now let's consider the number of carbon atoms. When we have one carbon atom, it is called met, 2 et, 3 probe, 4 boost. You can check my previous video lessons on hydrocarbons where I made mention of the list of members of the alkane series. Okay, so we have monkey eats plenty banana for the first 4 members. The next members are indicated from the Latin or Greek name for numbering. Okay, we have the tenths. 6 is X, 7 is X, 8 is oct, 9 is non, and 10 is dec. So for this video lesson, we are going to focus on the first 10 members, which is met to dec. Okay, so the group B, which is the word root, indicates the number of carbon atom in the longest continuous carbon chain of an organic compound. Make sense? Can we consider the next part of the order of naming organic compound, which is the suffix? The suffix indicates the family name of the organic compound, that is the functional group name. But this suffix is subdivided into, we have the primary suffix and the secondary suffix. What is primary suffix? The primary suffix indicates the nature of the carbon to carbon bond in the longest carbon chain. Now, the carbon bond can be carbon to carbon single bond. We can as well have the carbon to carbon double bond, and we can also have carbon to carbon triple bond in a carbon chain. Whenever we have the carbon to carbon single bond all through in a compound, the nomenclature ends with "ane", which indicates single bond. When the carbon chain contains a double bond, the nomenclature ends with "ene", E-N-E. In an instance whereby it contains carbon to carbon triple bond, the nomenclature ends with "ine". So when we have both carbon to carbon double bond and the carbon to carbon triple bond in an organic structure, we are expected to consider the order of priority of the bonds. Okay, now the carbon to carbon double bond has priority over the carbon to carbon triple bond. This was explained in the previous series on functional group of organic compound, where we discussed the priority list of the functional group. So this implies that carbon to carbon double bond, which is for the alkene, has priority over the carbon to carbon triple bond. So when we are numbering the organic compound that contains carbon to carbon double bond as well as the carbon to carbon triple bond, we assign the higher priority to the carbon to carbon double bond. That is, the alkene homologous series has priority over the alkyne series. Okay, now we are going to follow this order of arrangement as well, that is the alphabetical order of arrangements. Okay, so the first thing we need to consider is the order of priority before we now take the alphabetical order of arrangements. We have the "in" coming before what? "ein" in alphabetical arrangements. Note that we have to remove the last E right here, since we are not ending the nomenclature, so E will be removed from the in. So we have EN, then before we write the IN, YNE, okay? We have the alphabet E right here because we are ending the nomenclature. So it is in, IN. So if you are yet to end the IUPAC nomenclature, you do not put the last alphabet E in the suffix. Make sense? Now let's consider the CYK right here. Assign the appropriate locant to the carbon chain. We are to assign the appropriate number to the carbon atoms in this chain. So I would like you to pause the video while you answer this question. Moving on, the first thing we need to understand is that in this carbon chain, we have two functional groups. Now, what are those functional groups? I have the carbon-to-carbon double bond as well as what? Carbon-to-carbon triple bond in this carbon chain. Now, between the carbon-to-carbon double bond and the carbon-to-carbon triple bond, which one has the higher priority? That's right, the carbon-to-carbon double bond is considered over the carbon-to-carbon triple bond. Therefore, we will start our counting from the side closer to the carbon-to-carbon double bond to indicate its higher what? Priority. Therefore, we have 1, 2, 3, 4, and 5. Okay, we've been able to assign the least number to this carbon and the highest number to this carbon. This is because this side is closer to the carbon-to-carbon double bond and otherwise for what? The carbon-to-carbon triple bond. Make sense? In addition to this particular question, I would like us to check our knowledge on what we've done so far, considering the group A, group B, and the group C. The first thing we need to understand is that the carbon skeleton here contains 5 carbons. Now, can we check through this? The number of carbon is 5, so we have pents. Where do I indicate the pents? We have pents for the word roots. Recall that the suffix are subdivided into the primary suffix and the secondary suffix. So right here we have the primary suffix, which is the functional what? Group of the organic compound. There are 2 functional groups in this chain. We have the in and we have the hein. What is the number for the in? We have it on carbon 1, so I will have it as 1 in. Remember that we have both double bond and triple bond in the same carbon chain. Therefore, I will not put the last E. Then, the triple bond is right on what? Carbon 4. That's correct. We have 4 ein. Okay? Considering the order of naming, I have the word root as what? Pents, and the suffix include the in and the ein. The in on carbon 1, while the ein is on carbon 4. Make sense? So when we get to the IUPAC rule, I can equally say that having the required number of hydrogen on this carbon skeleton, the name of the compound will be, can you try? Yes, that's correct. Pents 1 in 4 ein. Make sense? Good. I told you that complex organic compound will be made simple in this class. So that's good. Moving on, we have the group D, which indicates the secondary suffix. Now, the secondary suffix includes the main group or the principal functional group in an organic compound. So all these are principal functional group in organic compound. But recall from our previous video that I said that functional group are arranged in order of priority. Okay, so I'm going to test your knowledge on the order of priority of functional group in this video lesson. So can we look closely at the table right here? I have alcohol, aldehyde, ketone, carboxylic acid, acid anhydride, acid amide, which is the same thing as the amide. We have the ester, the amine, the nitrile, and the thiol. Now, we need to arrange this in order of priority. I would like you to pause the video and take time to look at the table on the screen. Then we now consider the order of priority of this group. All right, can we attempt this together? We are to arrange this group in order of priority. So let us identify the principal functional group in this particular table. Now, the principal functional group in this table is the carboxylic acid. So I will assign 1 to the carboxylic acid functional group right here. Now recall that we identified the derivatives of the carboxylic acid. So the next functional group will be the acid anhydride. After the acid anhydride, we have the esters. After esters is what? That's correct. We have the acid amide. Then after acid amide, we now move to the nitrile. We have nitrile right here. Nitrile is number 5. After the nitrile, we have the aldehyde. Okay, number 6 is aldehyde. The next one in order of priority is what? The ketone. After ketone, we have the alcohol. Okay, alcohol is number 8. After the alcohol, we have the thiol, which is number 9. After the thiol, then the last one in this series is the amine. Okay, makes sense? So the functional group on this table with the highest priority is the carboxylic acid. Carboxylic acid greater than the acid anhydride. Acid anhydride is greater than the esters. Esters are greater than the acid amide. Acid amide is greater than the nitrile. Nitrile is greater than the aldehyde. Aldehyde is greater than the ketone. Okay, the ketone is greater than the alcohol. The alcohol is greater than the thiol, and the thiol is greater than the amine. In this series, amine is of the least priority, while the highest priority is given to what? The carboxylic acid. So if we have all these groups in an organic compound, the principal functional group is the carboxylic acid, while the least functional group is what? The amine. Make sense? Can we look at the order of naming together again? We have the prefix, word root, and suffix. So we have the prefix before the word roots, then before we have the suffix. Group A, which is the prefix, contains what? The subsequent group or the side chain in the longest continuous carbon chain, while the group B is the word root, which indicates the number of carbon atoms in the organic structure. Then group C is the primary suffix, which indicates the nature of the carbon-to-carbon bond. Is it carbon-to-carbon single bond, or carbon-to-carbon multiple bond, double bond, or triple bond? Okay, that is what we have in the primary suffix. While the secondary suffix indicates the main functional group or the principal functional group that we have in the organic compound. So we need to understand that when considering the IUPAC nomenclature of organic compound, we follow the order prefix, word root, suffix. Make sense? So I want to believe that from this video lesson, I've been able to simplify the order of naming of organic compounds. So in our next video lesson, we'll be considering the rules guiding the IUPAC nomenclature of organic compounds. So if you find this video lesson so interesting, kindly click the subscribe button and share with your friends right now. You can also follow and like my Facebook page. Thanks for watching.